Welcome to Spaceverse, your portal to cosmic adventures. Imagine looking up at the night sky and seeing misty mountains of gas illuminated by shimmering starlight, like something pulled straight from the pages of a fantasy epic. But what you're seeing now is no work of fiction. This is a real place, a breathtaking image captured by the James Webb Space Telescope, revealing part of a colossal cosmic landscape located nearly 5,500 light-years away from our planet. It's called NGC 6357, though many know it by its evocative nickname, the Lobster Nebula, nestled deep in the constellation of Scorpius, the Scorpion. NGC 6357 is a sprawling region of space, a turbulent ocean of molecular hydrogen gas, dust, and radiation. It's not just beautiful, it's alive with activity. This is what astronomers call a stellar nursery, a place where stars are born in furious bursts of creation. Inside its heart lies a dense cluster of blazing, young stars known as Pismis 24. These stars are immense, hot, and powerful, and their intense ultraviolet light is carving away at the very clouds that form them. Over millions of years, this light has hollowed out an enormous cavity within the nebula, sculpting walls of glowing gas that stretch for dozens of light-years in every direction. The James Webb Space Telescope, or JWST, used its near-infrared camera, called NIRCam, to peer into this stellar nursery. And what it revealed is jaw-dropping. The image shows only a small part of this gigantic nebula, just the inner edge of its vast cavity. But what we see there is extraordinary, a jagged mountain range of gas rising like colossal stone spires. These towering pillars are made of cold molecular gas and dust, shaped by the relentless radiation streaming from the young stars nearby. To understand the scale here, let's focus on the largest spire visible in this Webb image. From its tip down to its base, it stretches across 5.4 light-years. Imagine that 1 light-year is about 5.9 trillion miles, so this single pillar is over 30 trillion miles tall. And just the tip of that pillar, the very point, is 0.14 light-years across, nearly 900 billion miles wide. You could place our entire solar system inside that tip 200 times over, all the way out to Neptune's orbit. It's hard to even grasp such scale. This isn't just big, it's on a scale almost beyond human comprehension. Within this nebula, some of the universe's most extreme stars are coming into existence. The brightest points in the image, glowing with signature diffraction spikes, are among the massive members of the Pismis 24 cluster. One of them stands out in particular, Pismis 24-1. For a time, astronomers thought this single star might be the most massive ever discovered, estimated at a staggering 300 times the mass of our Sun. To put that in perspective, our Sun is already more than 99.8% of the mass of the entire solar system, and yet Pismis 24-1 was thought to be hundreds of times heavier than that. But as science often shows us, the closer we look, the more surprises we find. In 2006, the Hubble Space Telescope took a closer view of the Pismis 24 cluster and revealed something fascinating. Pismis 24-1 isn't just one enormous star. It's actually a triple star system. Hubble was able to separate two of the stars, discovering that one of them weighs in at about 66 times the mass of the Sun. The other two stars are so close together that neither Hubble nor even the powerful James Webb can visually distinguish them as separate points. Instead, astronomers had to detect their gravitational dance using the Doppler effect, watching their spectral lines shift as they orbit one another. This pair is what astronomers call a spectroscopic binary, and each of them is estimated to be about 36 times the mass of the Sun. These three stars together are extraordinary. Stars that massive live fast and die young, burning through their nuclear fuel in only a few million years. That's a blink of an eye compared to the Sun's expected lifetime of 10 billion years. All three of these stellar giants are destined to end in spectacular supernova explosions, perhaps within just 1 million years from now. Those future explosions will be powerful enough to briefly outshine entire galaxies, blasting heavy elements out into space, elements that will someday seed new generations of stars, planets, and maybe even life. The largest spire of gas in the Webb image almost seems to be reaching toward Pismis 24-1, like a cosmic finger pointing at its creator. The surrounding gas has been stripped away by the intense ultraviolet radiation from the cluster stars, but the pillar itself has survived because its material is denser, allowing it to resist the onslaught. Even so, it's not untouched. The relentless radiation and stellar winds are compressing the gas within the pillar, stirring it up and triggering gravitational collapse. This is the beginning of new star formation. Hidden inside, dense knots of gas are contracting under their own gravity, heating up, and will eventually ignite nuclear fusion. When they do, they will light up as newborn stars. Over time, those young stars will grow hotter and brighter, and their radiation will erode away the pillar from within. Eventually, they will emerge from their dusty cocoon as fully fledged stars, drifting free into the Milky Way. It's a cycle of cosmic creation. Clouds become stars, stars sculpt the clouds, and new stars are born from the remnants. What Webb has captured is a snapshot of this eternal dance, frozen in time but constantly changing on the scale of millions of years. The Lobster Nebula itself is enormous, spanning well over 400 light-years across. It's part of a larger region of star formation within the Scorpius constellation, and it contains several other clusters of young stars besides Pismis 24. The sheer amount of raw material here, molecular hydrogen, dust, and other gases, makes it a stellar nursery of immense potential. Over the next tens of millions of years, countless new stars will be born here, while older stars will die, explode, and enrich the surrounding gas with heavier elements, which will in turn form new stars and planets. It's an endless cycle of birth and death on a galactic scale. One of the most powerful things about the James Webb Space Telescope is its ability to see through the dense dust clouds that would normally block our view. Its infrared vision lets it peer deep into regions like NGC 6357, revealing structures and stars that are invisible in visible light. While Hubble showed us the breathtaking beauty of nebulae in visible wavelengths, Webb goes further, unveiling what's hidden within, like seeing the machinery of star formation exposed for the first time. It's as if we are peering behind the curtain of creation itself. Astronomers study these regions not only for their beauty, but to answer profound questions. How do massive stars form? Why do some stars grow to hundreds of times the sun's mass while others remain small and faint? How do massive clusters like Pismis 24 influence their surroundings? The answers are written in places like the Lobster Nebula, and telescopes like Webb are giving us the tools to read them. By observing different regions at different stages of star formation, scientists can piece together the story of how stars, and by extension, planets and life, come to be. Consider for a moment that everything we are, every atom of carbon in our bodies, every atom of oxygen we breathe, the calcium in our bones, and the iron in our blood, was forged long ago inside massive stars like those in Pismis 24. When those stars died in cataclysmic explosions, they scattered their elements across space. Those atoms drifted for billions of years, eventually becoming part of clouds of gas and dust like NGC 6357. And from those clouds, new stars and planets formed, including our own Sun and Earth. When we look at a stellar nursery like the Lobster Nebula, we are looking at the raw material of future worlds, the cradle of tomorrow's suns, and the birthplace of life's ingredients. It's humbling to realize that places like this are not rare. The Milky Way is filled with star-forming nebulae. Yet each one is unique, shaped by the particular dance of gravity, radiation, and time that sculpts its clouds. Webb's image of NGC 6357 offers just a glimpse into one of these vast cosmic foundries, and even that glimpse is enough to inspire awe. The story of the Lobster Nebula and the Pismis 24 cluster is a story of creation on a grand scale, stars born from chaos, carving beauty from darkness, living brief and brilliant lives, and then dying in explosions that spread the seeds of new stars. It's a reminder that the universe is not static. It is alive, dynamic, and ever-changing. Even now, as you listen, new stars are being born inside those jagged pillars of gas, while ancient starlight from their predecessors travels across the void to reach us. The James Webb Space Telescope is more than just a scientific instrument. It's a time machine and a storyteller showing us chapters of the universe's grand narrative that were hidden until now. As we continue to explore the cosmos with Webb, we will no doubt find more stellar nurseries like NGC 6357, more giant stars defying our expectations, and more breathtaking vistas that remind us how small we are and how connected we are to the universe around us. This is the power of exploration. The more we learn, the more we realize how much there still is to discover. Somewhere out there in the swirling gas of the Lobster Nebula, stars are forming that could one day light the skies of distant worlds or give birth to planets where life may emerge. And perhaps, far in the future, other beings will look back at their own night skies, see the light of their sun, and wonder how it all began. Thanks for exploring the cosmos with us. If you enjoyed this journey, like, share, and subscribe to Spaceverse, and hit the bell so you never miss our next adventure. Until next time, keep looking up.